the anoxia is really fascinating from a chemistry perspective. From a biology perspective, I'm guessing some cold water fish that would prefer to live where it's cold, but there's no oxygen, and fish can't live where there's no oxygen. What does it do to the fish biology in these lakes when they're really anoxic for a period of time long enough that it might impact it?
So the cautionary tale, there's really two cautionary tales that impacted people's thinking about this. One is China Lake, which basically has no cold water fish left. So if this is a gradual process, you just reduce the survival rate of the fish. And so they don't do well. And a lot of these fish are stocked. But so there's two things that happen. The fish aren't reproducing, so you don't have the next generation of fish. And the state stops stocking fish in lakes that don't support cold water fishery. So it's kind of a double whammy. And then the other cautionary tale is Lake Auburn. And 2 years ago, Lake Auburn had a fairly significant fish kill. It's the water supply to the city of Lewiston. And all of a sudden, all the lake trout came to the surface belly up. And so if the anoxia comes on suddenly, which it can, particularly if you have a rain event that amplifies that, you can get fish kills. And so fish kills are not unusual. We haven't had fish kills in the Belgrade. It's kind of like they fade away. They don't come belly up. But both of those are possible.
420 times a week you get data from one of those buoys.
What, 400?
420 times a week.
Yeah.
Just from one buoy, that's a decent number.
Yeah.
And I presume you'd
And we're measuring 30 variables.
Yeah, and I presume you'd like to at least to keep some of this for historic purposes, but that's a whole lot of data to keep for a time. Are you sort of averaging this, or how are you optimizing that for, because you're not going to have the storage space to keep all of that stuff.
Yeah, I am. I mean, I can buy a terabyte drive on my Mac for $100.
And it will store all of that?
Yeah, I got 100 years of buoy data on a terabyte drive, easily. Now, we've got other problems. I've got lots of other data streams that I am going to work on, but the buoy data is 50, 60 megabytes a year. So that's doable. It's actually the process files that are going to get you to be a problem, because then once you turn it into a graphic, then you know, my PowerPoint presentation was bigger than the buoy data for the whole year, because I had graphics files in it that take up a lot of data. So you're absolutely right. We got to worry about the data piece and the archival piece. And I've actually been working with Susie on a WordPress-based tool where you can come in and say, I collected these samples today. You can upload your data. It's on a shared resource so that it's easy for all of our collaborators to use. And I don't expect I'm going to hit a real data limit on that in the near future. I'm optimistic, but I'm a kind of a glass half full kind of person.
One buoy so far?
Well, one buoy, but we're collaborating with a group. There's 7 of these buoys in the state of Maine. They're all being run by different people, but it's all the same company, because once it works, everyone starts comparing notes, right? There might be a buoy in Sebago in the next year. There's going to be a lot of these buoys. How many buoys do you guys maintain in the Saco River estuary?
4 large ones, the MTI buoys, and then 2 Lobos and 30 small ones.
See? All right, so he's going to run out of data in 50 years. I'm going to run out of space in 100 years. But are you worried about the data? Not really. Yeah, I think that's, I don't mean to make light of it, but the data stream in a digital form is not terrible. Once we turn it into graphics that are now interesting, then we have problems. Yeah.
How many of these lake associations are like in Maine? Because I feel Belgrade, is that the name?
Yeah.
Is really lucky to have you and your whole community work on it. There must be others that are desperate that don't have that kind of support.
Right.
This is the haves versus have.
Right. So it helps that there's a college 7 miles away. Right? I mean, it helps in lots of ways. It also helps that many of our donors are the same donors that live on the lakes, and we have lots of alums there. And so all of that works in a sort of a fundraising symbiosis that's not lost on me. One of the goals is to create a plan that is extendable. so that other organizations can use these. So we're doing a lot of the data analysis, and we're going to be building modules both in Excel and in R that people can use to analyze the data. Not only the data that we collect with more specialized instrumentation, but data that the state is collecting. So the state actually has a very good volunteer lake monitoring program with good quality control, about 1,000 volunteers. They're monitoring about 1,800 lakes across the state, often not with the frequency they would need in an ideal situation, but in enough frequency that you can look at long-term trends. So one of our goals is to create a package of analysis tools that, let's say, a sophisticated lake association could use. That's not the ideal solution, but it's a start in the right direction.
So when I was in college in the 70s, we would hear a lot in environmental science about acidification from power plants and acidification of lakes in the Northeast. Does that have any role in
No, there's enough carbonate in the groundwater. There's enough carbonate in the soils around the Belgrades that the pH is fine. And quite frankly, the decrease in sulfur has significantly decreased the acidity of our rain. So the yeah, in Maine. So if you're in the Adirondacks, you still have a problem because you're in a granitic. These high altitude granitic lakes don't have a significant buffer capacity. So they're doing things like flying in limestone and dumping them in the lakes. And I don't know exactly. They are slowly recovering, but once they become acidic, it's a slow process based on natural recovery. You'd have to probably give them a bump to get the pH back up.
So having done some of this oxygen gathering, again in the 70s, what is the technology now for sampling the oxygen and fixing it in order to analyze it?
It uses a ruthenium Bippy fluorometer. So it uses a metal porphyrin molecule that fluoresces in the absence of oxygen. So it's completely reagentless. It's a membrane. You hit it with a blue laser. That molecule fluoresces for a couple hundred microseconds, but in the presence of oxygen, it gets quenched. And so what you actually do is you measure the quenching time of that molecule. So these sensors last about a year. Their calibration lasts about 2 months. And they're essentially reagentless, so it's a completely different game. So that's a really good example, because you were doing Winkler titrations. Yeah, and that from a chemistry standpoint, that's wonderful. It's beautiful chemistry, but these sensors are cool. And this membrane you can take, it's a little disc. You can actually stick it inside of an Erlenmeyer flask and probe it from the outside with a laser. So a lot of biologists are using it to look at metabolism studies in their lab cultures. So this reagentless technique has completely changed the way we sample oxygen. And that's going to happen in all of our measurements. It's a good example in oxygen, and oxygen is really important, so there's a lot of money going into that. But there's other sensors. The person that comes up with a phosphorus sensor that can really do the job at measuring phosphorus in real time is going to make a lot of money. We're not there yet.
Does Maine make a distinction between lakes and ponds by area or anything like that? I'm asking because I have a camp on a pond.
Yeah. Okay. So the definition, the limnological definition of the difference between a lake and a pond is a pond is shallow enough that aquatic plants can grow all the way across the bottom of the pond. Okay. So it's typically less than 20 feet deep.
And would the state be monitoring these as well?
Yes, anything over 10 acres. So the state takes a much more practical standpoint, because the biggest lake in the Belgrades is Great Pond. Okay, right? Which is next to Miselis Lake, also known as Snow Pond. So this pond lake thing does not work from a limnological standpoint. It's whoever got there first and named it. Right? And Miselis was named a lot sooner than Snow Pond. It's the same lake. Right? But 10 acres is the state of Maine rule. So anything over 10 acres is considered a great pond by Maine statute, and then that's in the public domain. So Anybody can go on it, and most of them have boat access.
Yeah, so that would be the monitoring data for that pond would.
Might be available if you go on to Lakes of Maine and you type in the name of your lake or pond, it'll search through the database. And there's about 1,800 water bodies in that database. Yeah.
Unity College is right next door to Colby.
Yep.
And we're doing a lot of water quality in Lake Winnicook, called Unity Pond. And I'm just wondering if you have any collaboration with any of our researchers.
There's a new chemist, and I'm trying to remember his name, but he actually just finished his PhD at the University of Maine, doing fluorescence-based monitoring, and we met a couple weeks ago and talked about some collaboration. So his name's Jim or James Killarney. Okay, so that's something that we just started a little while ago, and we may end up doing some things because we have some instrumentation that he might be particularly interested in using. So maybe not the field work, but take the samples back and run them. Yeah.
So you're using a lot of historical data from Maine to go back in time. And like the storage might not be an issue, but do you run into issues with using that historical data where it's not always very clear what people were doing 40 years ago? And what kinds of techniques have you used to try to figure that out?
Yeah, so that's a really good question. We're fortunate that the Maine Department of Environmental Protection has a pretty rigorous quality analysis and quality control program. So when they make oxygen measurements, they're also making temperature measurements, and every meter, when they go down into the lake, they have to come up to certain QC points and reconfirm their data. So that's the good news. But you have to worry about that a bit. So you have to look at the data and ask, does it make sense? And so you can't just use a computer script to analyze the data and say, here's the number. Eventually, you got to put eyeballs on the data, which is a challenge, and say, does this data look reasonable? And our ability to do pattern recognition is actually way better than a computer's current ability to do pattern recognition. So it's a challenge. The biggest challenge isn't really the quality of the data, it's the sampling frequency. What we'd really like is an August 1972 sample from China Lake. Doesn't exist. You know, they sampled twice a year, that's what you got. And so our biggest data limitation is the absence of data, probably as opposed to the quality of the data. The quality's okay, it's the frequency that's given us trouble.
Once you return the oxygen levels to where you want to get them by whatever intervention, are there biologics you can introduce to the lake that will maintain the pH, the phosphorus system moving forward?
No, not really. Okay. Yes and no. I should be fair. There is a whole area of limnology that uses biomanipulation, and basically they would take the perch species out because the perch eat the zooplankton, and the zooplankton eat the phytoplankton. So there have been attempts to biologically manipulate the plankton population by messing with the food web. It's a lot of work, and I'm not convinced that that's the best strategy. The best strategy is to keep the phosphorus out of the lake, so we have to do two things. Everyone around the lake has to reduce their non-point source load, and then you got to fix it. And if they ask me, we should not be able to put a bubbler or aluminum in these lakes until everyone around the lake drank the Kool-Aid and agreed to have their septic tank tested and their camp road fixed. This idea that we're going to engineer ourselves out of a problem and we'll just spend $3 million on it every 20 years is kind of the wrong approach. It's a good approach if everything else is being done to prevent the problem from reoccurring. Let's have a conversation in a year and see how successful that point of view was.
Can I just comment on that? I agree completely, and I think, where, we take a look, we live in an environment because we love it, but what we do is we try to impose an environment onto it that shouldn't be there. So these great sweeping lawns, and we have to have these species that are not native, and in order for them to thrive, we have to add phosphorus, we have to add chemicals, And I think, you know, until people, you're right, understand that in order to live in an environment, you have to really live in it and not impose upon it. That's the only way it's going to work.
The real estate agents are now finding that houses that are built to Lake Smart standard, which don't have the big lawns that reduce the phosphorus runoff, are now selling at a premium in the Belgrades. But it's a lake by lake thing. There's a culture to a lake. You've been to a lake, and you're like, oh, this lake is cool. It appeals to you for certain reasons. It appeals to other people for different reasons. And so different types of people live on different types of lakes, and what is appealing to them is different. But we're starting to see a change in the attitude where a more natural ecosystem is a selling point versus a detriment. And that's good news from a lake health standpoint. Okay.